Hi everyone, welcome to this module, Reliable Networks. Network Architecture. Have you ever been busy working online only to have the internet go down? As you know by now, the internet didn't go down. You just lost your connection to it. It's very frustrating, with so many people in the world relying on network access to work and learn. It's imperative that networks are reliable. In this context, reliability means more than your connection to the internet. This topic focuses on four aspects of network reliability. The role of the network has changed from a data-only network to a system that enables the connection of people, devices, and information in a media reach, coverage, and network environments. For networks to function efficiently and grow in this type of environments, the network must be built upon a standard network architecture. Networks also support a wide range of applications and services. They must operate over many different types of cables and devices, which make up the physical infrastructure. The term network architecture in this context refers to the technologies that support the infrastructure and the programmed service and rules, or protocols, that move data across the network. As network evolve, as network evolve, we have learned that there are four basic characteristics that network architecture must address to meet user expectation. The first point is fault tolerance, the next is scalability, quality of service, and security. And the first point is fault tolerance. A fault tolerance network is one that limits the number of affected devices during a failure. It's built to allow quick recovery when such a failure occurs. These networks depend on multiple paths between the source and destination of message. If one path fails, the messages are instantly sent over a different link. Having multiple paths to a destination is known as redundancy. Implementing a packet switch network is one way to relieve networks provide redundancy. Packet switching splits traffic into packets that are routed over a shared network. A single message, such as email or video stream, is broken into multiple message blocks called packets. Each packet has the necessary addressing information of the source and destination of the message. The router within the network switches the packets based on the condition of the network at that moment. This means that all the packets in a single message could take very different paths to the same destination. In the figure, the user is unaware and unaffected by the router that is dynamically changing the router when a link fails. Okay. Redundant connection allow for alternative paths if a device or a link fail. The user experience is unaffected. Okay. This is the first path and color red, and the last this is the fine connection in color green. The next point is scalability. A scalable network expands quickly to support new users and applications. It does it without degrading the performance of services that are being accessed by existing users. The figure shows how a new network is easy add to an existing network. These networks are scalable because they design follow a set of standards and protocol. This lets software and hardware vendors focus on improving products and services without having to design a new set of rules for operating with the network within the network. And additional users and whole networks can be connected to the internet without degrading performance for existing users. Quality of service. Quality of service is an increasing requirements of networks today. New applications available to users over network, such as voice and live video streaming, creates high expectations for the quality of the delivery service. Have you ever tried to watch a video with constant break and pause? As data, voice and video content continue to converge onto the same network, cost becomes a primary mechanism for managing congestion and ensuring reliable delivery of content to all users. Congestion occurs when the demand of bandwidth exceeds the amount available. Network bandwidth is measured in the number of bits that can be transmitted in a single second, or bits per second (bps), when simultaneous communication are attempted across the network. The demand for network bandwidth can exceed its availability, creating network congestion. When the volume of traffic is greater than what can be transported across the network, devices will hold the packet in memory until resources become available to transmit them. In the figure, one user is requesting a web page and another is on a phone call. With cost policy in place, the router can manage the flow of the data and voice traffic, giving priority to voice communication if the network experiences congestion. The focus on quality of service is to prioritize time-sensitive traffic. The type of traffic, not the content of the traffic, is what is important. Quality of service managed by the router ensures that priorities and match with the type of communication and its importance to the organization. Web page can usually receive a lower priority. A voice over IP can will need priority to maintain a smooth, uninterrupted user experience. The next point is network security. The network infrastructure service and the data contained on network attached devices are crucial personal and business assets. Network administrator must address two types of network security concern: network infrastructure security and information security. Security. The network infrastructure includes physical security devices that provide network connectivity and preventing unauthorized access to the management software that reside on them, as shown in the figure. Administrator can protect the network with software and hardware security and by preventing physical access to the network device. Login, password, security measures protect the network from unauthorized access. Network administrator must also protect the information contained within the packet being transmitted over the network and the information stored on network attached device. In order to achieve the goals of network security, there are three primary requirements. Confidentiality. Data confidentiality means that only the intended and authorized recipients can access to read data. And the next is integrity. Data integrity ensures users that the information has not been altered in transmission from origin to destination. And the last point is availability. Data availability assures users of timely and reliable access to the data service for authorized users. Finish with your understanding. Question 1. When designers follow a set of standards and protocols, which of the four basic characteristics of network architecture is achieved? Mm, okay, when designers follow a set of standards and protocol, which of the four basic characteristics of network architecture is available? Scalability happens when designers follow a set of standards and protocols. Scalability And confidentiality, integrity, and availability are requirements of which of the four basic characteristics of network architecture. Okay, question 3. Which with which type of policy a router can manage the flow of the data and voice traffic, giving priority to voice communication if the network experiences congestion. Quality of service. Having multiple paths to the destination is known as redundancy. This is an example of which characteristic of network architecture. Fault tolerance. And the next topic, hierarchical network design. Physical and logical address. A person's name usually does not change. A person's address, on the other hand, relates to where the person lives and can change. On a host, the MAC address does not change. It's physically assigned to the host NIC and is known as the physical address. NIC is a network interface network ID card, and MAC is media access control. The physical address remains the same regardless of where the host is placed on the network. The IP address is similar to the address of a person. It's known as a logical address because it's assigned logical based on where the host is located. The IP address of network address is assigned to each host by a network administrator based on a local network. IP address contains two parts. One part identifies the network portion. The network portion of the IP address will be the same for all hosts connected to the same local network. The second part of the IP address identifies the individual host on that network, within same local network. The host portion of the IP address is unique to each host, as shown in the figure, but the physical MAC and logical IP address are required for a computer to communicate on a hierarchical network, just like both the name and address of a person are required to send a letter. And this is the explain network with this portion of IP address, and this is the portion of IP address. The number in red color is the portion of host address. And la view wireless and warning information. Okay. View wireless and warning information. View okay. Part one. Identify the work PCs next. Identify the use, the system, the network icons. Background. Okay. Well, and this is for the next. Continue with hierarchical analogy. Imagine how difficult communication would be if the only way to send a message to someone was to use a personal name. If there were no street address, cities, towns, or country boundaries, delivering a message to a specific person across the world would be really impossible. Click H button below for an example of hierarchical way to point-to-point allocation. North America, Canada, Nova Scotia, and Halifax. On Ethernet network, the host MAC address is similar to a personal name. A MAC address indicates the individual identifier of a specific host, but this does not indicate where on the network the host is located. If all hosts on the Internet, millions and millions of them, were each identified by their unique MAC address only, imagine how difficult it would be to locate a single one. Additional, Ethernet technology generates a large amount of broadcast traffic in order for hosts to communicate. Broadcasts are sent to all hosts within a single network. Broadcasts consume bandwidth and slow network performance. What would happen if the millions of hosts attached to the Internet were all in one Ethernet network and were using broadcast? For these two reasons, large Ethernet networks consist of many hosts are not efficient. It's better to divide large network into smaller, more managed pieces. One way to divide large network is to use a hierarchical design model. Access distribution and core IP traffic is managed based on the characteristics and device associated with each of the three layers of the hierarchical network design model: access, distribution, and core. The first layer is access. The access layer provides a connection point for end users' devices to the network and allow multiple hosts to connect to other hosts through a network device, usually a switch. Switch at the Cisco 2960XR, shown in the figure, or a wireless access point. Typically, all devices within a single access layer will have the same network portion of the IP address. If a message is destined for a local host based on the network portion of the IP, the message remains local. If it's destined for a different network, it's passed up to the distribution layer. Switches provide the connection to the distribution layer, usually a layer 3 devices such as a router or layer 3 switch. This is switch 2960XR. This is a switch for layer 2 or layer MAC bus and media access control. The next is distribution layer. The distribution layer provides a connection point to separate networks and control the flow of information between the networks. It typically contains more powerful switches, such as Cisco C9300 series shown in the figure, that can access layer as well as router for routing between networks. Distribution layer devices control the type and amount of traffic that flow from the access layer to the core layer. Okay, this is a switch C9300 series. Is a switch layer 3 the distribution of bus based in IP addresses. And the last is core layer. The core layer is a high-speed backbone layer with redundancy, backup connection. It's responsible for transporting large amounts of data between multiple ends networks. Core layer device typically includes very powerful, high-speed switch and router, such as the Cisco Catalyst and 9600. Shown in the figure, the main goal of the core layer is to transport data quickly. And this is the Cisco Catalyst 9600 of core layer. Finish with check your understanding. Question 1. An IP address is considered what type of address? Logical. The Ethernet MAC address is considered physical. Which address does not change when a device is connected to a new network? Physical. Which portion of IP address unlikely identifies that device on the network? Host. and which design layer provide connectivity to devices on an Ethernet LAN. That is access layer.